Example 4, we're looking at the equation 5y to the fourth minus y squared plus y is equal to x squared plus 2y. And of course the goal is to find dy dx, or if you like, y prime. They're the same thing, just different notation. Don't know why we use 3 different notations for derivatives, but alas, it's the life we live. Alright, so how do we derive this? Again, that's the first step when we do any implicit differentiation problem. We have to derive both sides in terms of x. Okay, so first thing we're going to do is derive this guy. Let's first put some parentheses around all of our y's to remind us that we're using the chain rule. All right. So let's derive this first term here, this 5y to the fourth. So what we're going to do is power rule. Chain rule technically, but power rule. Bring the 4 down in front so you have 20 times y to the third. So we just derived the outside bit. Now we need to multiply by the derivative of the inside, which is y prime. Okay? So that takes care of the first term. Second term, this guy. We're going to do the exact same thing. We're going to take this 2, bring it down in front, and then multiply by the derivative of the inside. So you've got to be very careful with this minus sign here. Make sure that that persists. That is, you bring it along. So you have minus 2y to the first times the derivative of the inside, which is y prime. I'd like to get rid of my first powers. So there you have that. So then you have this third term, which is just y. So how do we derive just y? That, you always have to keep in mind, is not going to turn into a 1, it turns into a y prime. Anytime you're deriving a y, you gotta be very careful that you're not making it just disappear. All right? So that's just y prime. So we handled the entire left-hand side this way. Now let's do the right. We have 2x for the first term, this guy. And then for the second term here, we have 2 times y. Again, the y doesn't just go away, it becomes y prime, since it doesn't have a power on it. So we have 2y prime. So that was the first step of the strategy. You derive both sides in terms of x implicitly. All right? The next step is to get all of your y prime stuff on one side and all of your non-y prime stuff on the other. So notice that everything on the left-hand side has a y prime attached to it. We have a y prime thing over here on the right-hand side. We're going to subtract that over because we don't have a y prime on this 2 times x. So doing this, we rewrite a lot. I'm going to drop the parentheses here. So we have 2 times y prime. Because they're all being multiplied, I can drop the parentheses. I have y prime here, and then I subtract away 2y prime here. And then this is all equal to 2x, which we're going to leave on the other side, because it doesn't have a y prime attached to it. Everything on the left-hand side has a y prime. So now what we're going to do is factor out our y prime, because we have a y prime in common across all 4 terms. All right? So that's what we're going to do. We have y prime times 20y cubed minus 2y plus 1 for this term here, and minus 2 for the last term, because we pulled off the y prime on both of those terms. And this entire thing is equal to 2x. So let's simplify this a little bit, because you might notice that, hey, look, we have a 1 and a minus 2. So technically speaking, that's just minus 1 when you combine those like terms. So we'll just write that. We'll just write minus 1 for the sake of cleaning it up. You can't really combine any other like terms, so we're good once we do that. The last step is to divide both sides by this lovely thing in parentheses so that we get y prime by itself. Okay, so then doing this cancels off the entirety of all of that stuff, And then this finally gives us y prime is equal to 2x over the massive thing, 20y cubed minus 2y minus 1. And that's the final answer. Yes, we did this for y prime, but y prime is also equal to dy dx. So you're good there. The same method applies. Doesn't matter if you ask for dy dx or y prime or f prime. Same thing. Just set it equal to what it needs to be at the end. So that was example number 4.